Hello, and welcome to this webinar presentation by Global-CPD Teacher Training Services. This presentation is on creating an impactful math curriculum and planning engaging lessons. Imagine a classroom where every student is not merely a passive receptor of information, but an active participant in their own learning journey. Imagine the spark in their eyes as they unravel the mysteries of algebra, geometry, and calculus, not as dry concepts, but as tools to comprehend the world around them. This is the transformation that engaging and impactful learning experiences can bring about. Today, our presentation is not a mere theoretical exploration. It is a treasure trove of practical strategies and valuable resources meticulously curated to elevate your teaching practices. We understand that the challenges of engaging young minds in the intricacies of math can be formidable, but armed with the right approaches, we can turn these challenges into opportunities for growth and inspiration. 1. Significance of collaborative planning in curriculum development, leveraging professional learning communities, PLCs. Professional learning communities, PLCs, provide a structured framework for teachers to collaborate effectively. Within these communities, educators come together to share insights, strategies, and best practices. This collaborative approach offers numerous benefits. Diverse expertise. Teachers bring their unique experiences and perspectives, enriching curriculum development with multifaceted insights. Innovative ideas. Brainstorming within PLCs generates innovative ways to blend curriculum content with real-world relevance. Addressing student needs. By pooling resources and knowledge, teachers can tailor curriculum to address varying student needs and learning styles. Continuous improvement. Collaborative planning enables ongoing refinement of curriculum based on feedback and results. Professional growth. Educators learn from each other's strengths, enhancing their teaching skills and subject expertise. Example: collaborative geometry project. Consider a group of math teachers forming a PLC to design a geometry project. They aim to engage students in designing architectural structures by blending mathematical concepts with real-world applications. Initial brainstorming. The teachers gather to brainstorm project ideas drawing from their diverse experiences. They envision a project that challenges students to design a sustainable building while applying geometric principles. Curriculum integration. Each teacher contributes their insights to integrate geometry concepts like angles, shapes, and measurements into the architectural design project. By combining theoretical learning with practical application, the project gains real-world relevance. Resource sharing. Teachers pool resources like relevant articles, software tools, and architectural examples to enrich the project's content. Assessment strategies. The PLC discusses assessment methods that gauge both mathematical understanding and the application of concepts in design. They consider rubrics that evaluate creativity, problem-solving, and collaboration skills. Feedback and refinement. As the project unfolds, the teachers gather feedback from students and make adjustments. They reconvene in the PLC to discuss the project's successes, challenges, and potential improvements for the next iteration. Through this collaborative effort, the teachers not only enhance the quality of the curriculum, but also model effective teamwork and problem-solving skills for their students. 2. Integrating real-world applications and authentic assessments. Authentic assessments and performance tasks. Authentic assessments, such as performance tasks, are evaluation methods that measure students' abilities to apply their knowledge and skills in real-world contexts. These assessments go beyond traditional tests by requiring students to demonstrate problem-solving skills, critical thinking, and creativity. Performance tasks mirror the types of challenges they might face in professional or personal situations, making assessment a practical learning experience in itself. Now, examine these steps of designing authentic assessments and think about how you can adapt this procedure to your planning. Example: analyzing sports data in a statistics lesson. Imagine a statistics lesson where students dive into the world of sports data analysis. They are tasked with analyzing data from their favorite sports teams, calculating averages, and predicting outcomes. Here's how authentic assessment and real-world integration come into play. Data collection and analysis. Students gather data such as players' scores, team statistics, and match results. They apply statistical concepts like mean, median, and mode to interpret the data, gaining practical insights into the team's performance. Predictive modeling. Using their mathematical skills, students create predictive models to forecast future game outcomes. This bridges the gap between theoretical concepts and practical decision-making, showcasing the relevance of math in making informed predictions. Problem-solving challenge. To assess their understanding, students are presented with a scenario where the team's performance needs improvement. They use statistical analysis to propose strategies for enhancing the team's performance, highlighting their problem-solving and critical thinking abilities. Communication skills. Students are required to present their findings and recommendations, honing their communication skills by explaining complex mathematical concepts in a clear and relatable manner. Real-life relevance. This approach connects math to a subject of genuine interest to students, making the learning experience engaging and meaningful. It also cultivates skills that are transferable to various contexts beyond the classroom. Scaffolding and gradual release of responsibility. The gradual release of responsibility model is a framework that aligns closely with scaffolding. It describes a transition in teaching from teacher-guided instruction to student-led learning. The model is often summarized in 4 stages. Teacher modeling. In this initial stage, the teacher demonstrates the concept or skill, explaining their thought process and strategies. Students observe and absorb the information. Guided instruction. The teacher provides structured support as students practice the new concept. This may involve working together on problems, with the teacher offering guidance and feedback. Collaborative learning. At this stage, students work in pairs or small groups. The teacher acts as a facilitator, stepping back while students apply what they've learned, discussing ideas, and collaborating to solve problems. Independent practice. In the final stage, students take on the responsibility of applying the concept or skill on their own. They work independently, demonstrating their understanding and mastery. Example: teaching algebra using gradual release. Consider the teaching of algebra using the gradual release model. Teacher modeling. The teacher introduces a new algebraic concept, such as solving linear equations. They work through examples step by step on the board, explaining each action and decision. Guided instruction. Students are provided with a set of equations to solve. The teacher works through a few problems together with the class, giving prompts and clarifications as needed. Collaborative learning. Students are divided into pairs. Each pair is given a set of equations to solve together. The teacher moves around the room, offering assistance when necessary, while students discuss strategies and problem-solving approaches. Independent practice. As students become more confident, they're assigned a set of equations to solve individually. The teacher is available for questions, but students primarily rely on their understanding and problem-solving skills developed through the previous stages. 3. Incorporating multicultural perspectives and inclusive practices. Inclusive practices. Catering to all students. Inclusive math education recognizes that students come from different backgrounds, learning styles, and experiences. By embracing this diversity, educators can create a classroom that caters to the needs of all students. Accessibility. Inclusive practices ensure that educational materials are accessible to everyone, regardless of their abilities. This can involve providing alternative formats or tools for students with different learning needs. Cultural relevance. Integrating diverse perspectives makes the curriculum more relatable and engaging. Students see themselves and their cultures reflected in the content, fostering a sense of belonging. Differentiated instruction. Recognizing diverse learning styles, educators can offer varied approaches to teaching and assessment, allowing each student to engage with the material in ways that resonate with them. Critical thinking. Exposure to different mathematical perspectives encourages students to question assumptions and think critically about the subject. This can lead to a deeper and more nuanced understanding. Example: incorporating cultural designs in geometry. Consider a geometry lesson that aims to explore the concepts of symmetry and design. In an inclusive classroom, the teacher might present designs from various cultures around the world, each showcasing distinct geometric principles. For instance, Islamic art. Students could study the intricate patterns found in Islamic art and architecture, which often utilize symmetrical geometry to create breathtaking designs. Indigenous patterns. Exploring indigenous art, students might learn about the symmetrical representations of nature in various cultures, such as Maori or Native American designs. African textiles. African textile patterns could be examined, showcasing rotational and reflective symmetries that hold cultural significance. Example: incorporating cultural designs in geometry. Consider a geometry lesson that aims to explore the concepts of symmetry and design. In an inclusive classroom, the teacher might present designs from various cultures around the world, each showcasing distinct geometric principles. For instance, Islamic art. Students could study the intricate patterns found in Islamic art and architecture, which often utilize symmetrical geometry to create breathtaking designs. Indigenous patterns. Exploring indigenous art, students might learn about the symmetrical representations of nature in various cultures, such as Maori or Native American designs. African textiles. African textile patterns could be examined, showcasing rotational and reflective symmetries that hold cultural significance. 4. Addressing common challenges and overcoming obstacles. Common challenges faced by math teachers. Math teachers often encounter various challenges in their classrooms, two of the most prevalent being time constraints and maintaining student motivation. Time constraints. The pressure to cover a curriculum within a limited time frame can lead to rushed lessons, leaving some students struggling to grasp concepts fully. Student motivation. Keeping students engaged and motivated can be a constant challenge, especially when some students find math intimidating or irrelevant to their lives. Strategies to overcome these challenges. A. Incorporating hands-on activities. Engaging students in hands-on math activities can deepen understanding and foster active participation. Practical exercises, such as using manipulatives or conducting experiments, make abstract concepts more tangible and memorable. This approach not only addresses time constraints by enhancing learning efficiency, but also boosts student motivation through interactive learning experiences. B. Differentiated instruction. Recognizing that students have varying learning styles and paces, implementing differentiated instruction caters to individual needs. Grouping students based on their levels allows teachers to provide targeted support and challenges, ensuring that every student progresses at their optimal pace. Differentiated instruction can also boost motivation, as students are more likely to engage when the material matches their abilities and interests. C. Theme-based learning. Implementing thematic units, such as Math Mondays, can create a consistent structure for math-related activities throughout the week. Themed days can involve solving real-world problems, exploring math in art or nature, and even incorporating technology for interactive learning. This approach integrates math into the students' weekly routine, combating time constraints by spreading out math engagement over several days. D. Gamification and competition. Incorporating elements of gamification and friendly competition can enhance student motivation. Math games, challenges, and competitions encourage students to apply their skills in a fun and engaging context. By transforming learning into an exciting experience, teachers can overcome student reluctance and invigorate their interest in math. Example: implementing Math Mondays. To address time constraints, a math teacher could establish Math Mondays. This approach involves setting aside a specific time each Monday for math-related activities that extend throughout the week. Math challenges. On Monday, students are presented with math challenges or puzzles that they work on throughout the week during designated times. Real-world applications. Tuesday might involve applying math concepts to real-world scenarios like budgeting, measurements, or data analysis. Hands-on exploration. Wednesday could be dedicated to hands-on activities, using manipulatives or conducting experiments that deepen understanding. Collaborative problem solving. Thursday could involve group problem-solving sessions, where students collaborate to tackle challenging math problems. Reflect and discuss. On Friday, students reflect on the week's activities, discussing their experiences and insights. Through this approach, students engage with math in diverse ways while accommodating the limited time available during regular lessons. 5. Utilizing resources and tools for curriculum enhancement. A world of possibilities. Exploring diverse tools. Open Educational Resources, OER. These freely accessible materials, including textbooks, videos, and lesson plans, can be customized to suit specific curriculum needs. OER promotes collaborative learning environments and reduces barriers to access educational content. Virtual and augmented reality, VR/AR. Immersive technologies allow students to venture beyond the classroom, exploring historical sites, scientific phenomena, or complex mathematical concepts in a visually engaging and interactive manner. Online platforms. Web-based platforms offer a treasure trove of resources, from interactive quizzes to multimedia presentations. They encourage self-paced learning, making education adaptable to different learning styles. Interactive simulations. Simulations provide hands-on experiences in subjects like science, mathematics, and engineering. Students can experiment in virtual environments, fostering deeper understanding through exploration. Professional development opportunities. Educators can access workshops, webinars, and training programs to stay updated on the latest teaching methodologies and technologies. These opportunities empower teachers to craft impactful learning experiences. Harnessing the power, a glimpse into resource application. Imagine a science classroom where students explore the solar system through augmented reality. They wear VR headsets to walk on the surface of Mars, navigate through the rings of Saturn, and witness the birth of stars. This experience transforms abstract concepts into vivid adventures, igniting curiosity and making learning unforgettable. In a mathematics class, students delve into the world of geometry using interactive simulations. They manipulate shapes, experiment with angles, and observe transformations in real time. This hands-on engagement allows them to internalize complex concepts while having fun. Professional development opportunities play a crucial role in this resource-rich landscape. Teachers attend workshops to learn how to integrate technology effectively, design engaging lesson plans, and cater to diverse student needs. As a result, they become well-equipped guides, leading students through a dynamic and evolving educational journey. Embrace the future, enriching learning experiences. Incorporating a variety of resources into the curriculum bridges the gap between theoretical learning and real-world application. It equips students with skills for the digital age, nurtures their critical thinking, and prepares them for a rapidly changing world. By embracing the potential of open educational resources, virtual and augmented reality, online platforms, interactive simulations, and ongoing professional development, educators empower students to be active participants in their education and future success. 6. Open Educational Resources, OER. The freedom of access and customization. OER are a treasure trove of educational materials available freely on the internet. From textbooks and lecture notes to worksheets and interactive modules, OER cover a broad spectrum of content. This availability enables educators to access a vast pool of resources without being bound by financial constraints or licensing issues. The freedom to access and distribute these materials fosters inclusivity, ensuring that every student has access to quality math education regardless of economic barriers. One of the defining strengths of OER lies in their adaptability. Educators can modify, remix, and tailor these resources to meet the unique needs of their students and teaching style. This flexibility empowers teachers to design learning materials that resonate with their classroom dynamics and individual student preferences, ultimately enhancing engagement and comprehension. Example: personalized learning with OER. Consider a mathematics teacher who is tasked with teaching algebra to a diverse group of students with varying skill levels. Utilizing OER, the teacher discovers a collection of algebra worksheets specifically designed for different proficiency tiers. Armed with this resource, the teacher customizes lesson plans by selecting worksheets that align with each student's abilities. For students who need reinforcement, the teacher assigns worksheets with fundamental algebraic concepts. Advanced students receive more challenging assignments that push their boundaries. This personalized approach addresses individual needs, boosting students' confidence and motivating them to excel. The result is a classroom where every student's potential is unlocked through tailored OER materials. The benefits of OER in math education: cost efficiency. OER eliminate the financial burden associated with traditional textbooks, making high-quality educational materials accessible to all students. Customization. Educators can adapt OER to match their teaching styles, students' learning preferences, and specific curriculum requirements. Innovation. OER encourage teachers to innovate by using a diverse range of resources, including interactive simulations, videos, and digital tools. Global collaboration. OER foster collaboration among educators worldwide, enabling the sharing of best practices, insights, and content creation. Continuous improvement. As OER materials are frequently updated and improved by the community, educators can access the latest advancements in mathematics education. 7. Virtual and augmented reality, VR/AR, in the classroom. Exploring geometric concepts in a virtual environment. Imagine a math classroom where students don VR headsets and are transported to a digital realm where geometric concepts come to life. This immersive experience opens doors to a multitude of learning scenarios. 3D shapes, exploration. In a traditional setting, visualizing and understanding complex 3D shapes can be challenging. With VR, students can manipulate and inspect these shapes from all angles, enhancing their spatial understanding and making abstract concepts tangible. Volume and surface area. Calculating the volume and surface area of irregular shapes becomes more intuitive in a VR environment. Students can virtually dissect objects, revealing their dimensions and enabling accurate measurements. Trigonometry in real space. Students can step into a VR environment where they interact with right triangles, visually experiencing trigonometric ratios and angles in a real space context. Graphing functions. In AR, students can overlay graphs of mathematical functions onto their physical surroundings, seeing how changes in equations impact the visual representation of the graph. Example: exploring complex 3D shapes. Consider a high school geometry class where students are introduced to intricate 3D shapes like dodecahedrons or rhombocubocctahedrons. These shapes can be challenging to comprehend on paper. However, with VR technology, students enter a virtual space where these shapes are projected in lifelike dimensions. Students can walk around the shapes, observe their unique facets, and even interact with them by dissecting or altering their dimensions. This immersive experience not only aids in visualizing the shapes, but also enhances spatial reasoning as students navigate through a three-dimensional landscape. Advantages of VR/AR in math learning. Engagement. The immersive nature of VR/AR captures students' attention and maintains their focus, leading to improved understanding and retention. Hands-on exploration. Students actively interact with mathematical concepts, fostering deeper understanding and practical application. Visualizing complex concepts. Abstract and challenging topics become more comprehensible through interactive visualizations in a virtual space. Personalized learning. Students can learn at their own pace, revisiting concepts as needed within the immersive environment. Real-world connection. VR/AR scenarios simulate real-world applications of math, helping students see the relevance of their learning. Example: exploring complex 3D shapes. Consider a high school geometry class where students are introduced to intricate 3D shapes like dodecahedrons or rhombocubocctahedrons. These shapes can be challenging to comprehend on paper. However, with VR technology, students enter a virtual space where these shapes are projected in lifelike dimensions. Students can walk around the shapes, observe their unique facets, and even interact with them by dissecting or altering their dimensions. This immersive experience not only aids in visualizing the shapes, but also enhances spatial reasoning as students navigate through a three-dimensional landscape. Advantages of VR/AR in math learning. Engagement. The immersive nature of VR/AR captures students' attention and maintains their focus, leading to improved understanding and retention. Hands-on exploration. Students actively interact with mathematical concepts, fostering deeper understanding and practical application. Visualizing complex concepts. Abstract and challenging topics become more comprehensible through interactive visualizations in a virtual space. Personalized learning. Students can learn at their own pace, revisiting concepts as needed within the immersive environment. Real-world connection. VR/AR scenarios simulate real-world applications of math, helping students see the relevance of their learning. 8. Online platforms and digital tools for math education. Visualizing functions and graph transformations. Imagine a math classroom where students access an online platform that provides interactive graphing tools. Here's how this resource can provide advantages. Function: visualization. Students can input equations and immediately see the corresponding graph. This hands-on interaction bridges the gap between mathematical notation and visual representation, helping students connect the abstract with the concrete. Graph transformations. The platform allows students to manipulate graphs by changing coefficients or parameters. They can observe real-time changes and how they impact the graph's shape, position, and orientation. Immediate feedback. As students experiment with functions and transformations, the platform provides instant feedback, helping them grasp cause and effect relationships in a dynamic manner. Example: exploring graph transformations. Consider a scenario where high school students are studying graph transformations. They log into an online platform that presents them with various functions like linear, quadratic, and exponential. Students can input different equations and observe how the graphs change in response. They can then apply transformations like translations, reflections, and stretches to the graphs, witnessing the effects in real time. For instance, they might input a linear function and experiment with changing the slope and y-intercept. The interactive graphing tool allows them to see how these changes influence the line's steepness and position on the coordinate plane. This immersive experience not only solidifies their understanding of graph transformations, but also fosters a sense of discovery and curiosity. Advantages of online platforms and digital tools. Engagement. Interactive features captivate students' attention, making learning more enjoyable and meaningful. Visualization. Visual elements enhance comprehension, especially in complex topics like graph transformations. Active learning. Students actively manipulate content, leading to better retention and understanding. Immediate feedback. Instant feedback guides students toward correct solutions and helps rectify misconceptions promptly. Differentiated learning. Platforms can adapt to individual learning paces, providing targeted practice for diverse skill levels. Online platforms and digital tools are catalysts for dynamic and engaging learning experiences. Through interactive exercises and visualizations, these resources transform abstract concepts into tangible experiences. The example of exploring graph transformations exemplifies how such tools empower students to actively engage with math, fostering deeper understanding and fostering a genuine passion for learning. As education evolves in the digital era, online platforms and digital tools will undoubtedly continue to play a pivotal role in shaping the future of learning. 9. Interactive simulations and virtual laboratories. Experimenting with mathematical concepts. Simulations and virtual labs play a crucial role in math education by providing students with a virtual environment where they can actively experiment with mathematical concepts. Through these platforms, students can visualize the outcomes of different mathematical scenarios, fostering a deeper understanding of how mathematical principles influence real-world phenomena. Example: exploring mathematical equations and real-world motion. Consider a physics class where students are learning about the relationships between mathematical equations and real-world motion. Using a virtual physics lab, students can experiment with different equations to understand how changes in variables like speed, acceleration, and time impact the trajectory of an object. For instance, students might adjust the initial velocity of a virtual projectile and observe how it affects the parabolic trajectory. By manipulating variables and witnessing the resulting changes in real time, students gain insights into the mathematical underpinnings of motion and the empirical implications of these equations. Advantages of simulations and virtual labs in math education. Concrete understanding. Simulations provide tangible visualizations, transforming abstract concepts into concrete experiences. Safe exploration. Virtual labs offer a risk-free environment for experimentation, allowing students to make mistakes and learn from them without real-world consequences. Real-time feedback. Immediate feedback helps students understand cause and effect relationships between variables and outcomes. Complex interactions. Simulations can replicate complex interactions that are difficult to observe in traditional classroom settings. Engagement. Interactive experiences keep students engaged and motivated to explore mathematical concepts further. 10. Professional development opportunities and networks. Benefits of attending workshops, conferences, and online courses. Enriched pedagogical skills. Workshops, conferences, and online courses offer educators the chance to learn about innovative teaching methodologies, instructional strategies, and the latest trends in education. This knowledge translates into more effective classroom practices that cater to diverse learning styles. Networking opportunities. These events bring educators together, fostering valuable connections with peers, mentors, and experts. Networking opens doors to collaborative opportunities, idea sharing, and the exchange of best practices. Fresh perspectives. Exposure to new ideas and viewpoints challenges educators to think outside the box. It encourages creative problem solving and stimulates innovation in curriculum, design, and lesson planning. Staying current, education is a dynamic field with constant advancements. Attending professional development events helps teachers stay updated with the latest research, technology, and pedagogical trends, ensuring that their teaching remains relevant and effective. Personal growth. Continuous professional development nurtures personal growth by building confidence, expanding knowledge, and fostering a growth mindset. This mindset, when modeled for students, encourages a culture of lifelong learning. Example: enhancing student engagement through gamification. Consider a math teacher attending a math education conference. In a session focused on student engagement, the teacher learns about gamification strategies. These strategies involve incorporating game elements, such as points, rewards, and competition, into the learning experience. Inspired by what was learned at the conference, the teacher applies gamification techniques in the classroom. They design math challenges that students can solve to earn points and rewards. By turning learning into a game, the teacher observes a noticeable increase in student engagement, participation, and enthusiasm for math. So now, as a conclusion, let's recap transformative strategies in math education. Today's discussion has encompassed a range of transformative strategies that hold the power to revolutionize math education, enriching the learning experience and fostering engagement. Collaborative planning. We explored how working together in professional learning communities can leverage collective expertise to design innovative projects, like combining math concepts with real-world applications in architecture. Real-world applications. By integrating practical scenarios into the curriculum, we enable students to see the relevance of math beyond the classroom, sparking their curiosity and fostering deeper comprehension. Scaffolding and gradual release. The gradual release of responsibility model was discussed, showcasing how educators can guide students from teacher-led instruction to independent learning, ensuring a balanced and effective learning journey. Inclusive practices. We highlighted the significance of embracing diverse perspectives and catering to individual student needs, creating an inclusive classroom where every learner feels valued and empowered. Overcoming challenges. Addressing common challenges like time constraints and student motivation, we explored strategies like hands-on activities and differentiated instruction that can turn obstacles into opportunities for growth. Utilizing resources. We uncovered the potential of open educational resources, virtual reality, augmented reality, online platforms, simulations, and professional development, all of which can elevate the educational experience. The integration of these strategies and tools can truly transform math education. By blending collaborative planning with real-world applications, scaffolding with inclusive practices, and resource utilization with overcoming challenges, we pave the way for engaging and effective learning environments. Thank you for investing your valuable time with us today. Remember, the best teacher is the best learner. Let's continue to learn, adapt, and thrive in our noble profession. Until next time, happy teaching. You can access the comprehensive PDF document associated with this presentation through the Learning Management System, Global-CPD, Continuing Professional Development for Teachers and School Leaders. Global-CPD is an organization with a vision to provide relevant, effective, and innovative professional development for teachers and educational leaders in English medium school and university contexts. Global-CPD offers professional development courses to teachers and administrators through a solid program of needs analysis by setting short, medium, and long-term goals for better quality education, and provision of specialized training programs with follow-up support. To learn more about Global-CPD work and services, contact us by email at admin@global-cpd.org or visit our website at www.global-cpd.org. Many of our services have online forms, which allow you to access services at any time that is convenient to you. Learning teachers lead the way.